Okay, so this is section 5-5, and now we're talking about trig equations. So at the beginning of this chapter, when I said we couldn't add, couldn't subtract, couldn't multiply, divide, square, square root, all those functions, we couldn't do those things to both sides. Now we can again. So it's an equation that contains a trig expression with a variable. And what we're going to be doing is solving these types of equations. Now, to understand what we're really asking here, I'm going to go ahead and graph the sine graph. So remember that starts at 0, ends at 0, halfway at 0. First quarter is up at our amplitude, third quarter is down at the negative amplitude. And there's our period. And we can copy and paste that again. Okay. And we have 1/2 right here. And so what I'm really asking myself is, where does sine x equal 1/2? Well, it equals it right here. It also equals 1/2 right here. It also equals 1/2 right here and here. And it goes on and on and on. And it actually continues on in this direction as well. So what we can do is we can just look at one period and see where it equals 1/2. And it equals 1/2 at these 2 points. X equals at pi over 6 and at 5 pi over 6. Okay, so it's kind of like asking inverse sine of 1/2, but the whole period, not just the restricted domain. So these are our values here, and what we're going to do is, because I can keep getting more and more values where, or angles where sine is equal to 1/2, I'm going to write plus 2 pi, but I can do that as many times as I want, so we'll write 2 pi n. And then we'll do the same thing here, where n is equal to 0, 1, 2, and so on. Okay, so those are our answers here. Now let's go ahead and solve a more complicated equation here. We have sine x minus 2 equals 5 sine x minus 1. So let's go ahead and solve this. And we can treat this kind of like just regular x's. So I have 3 sine x over here and 5 over here, so I'm going to subtract 3 sine x. And I'm going to add 1. And those cancel, that cancels. Negative 2 plus 1 is negative 1. And 5 minus 3 is 2 sine x. And now I can divide by 2. So negative 1/2 equals sine x. So what we're asking is, where does it equal this? X is equal to 7 pi over 6, and x is equal to 11 pi over 6 plus 2 pi n plus 2 pi n. And those are our answers. So that's what we're doing in this section, in section 5. I'm going to go ahead and flip the page. And now we have a new one, a new equation. And this one is with tangent. We'll do the same thing, but there is one thing that's different about this equation. And it's right here. We have a 3x instead of just x. So what I'm going to do is I'm going to rewrite that as theta. Okay, so tangent of theta is equal to 1. Well, that happens on tangents period when theta equals pi over 4. And on tangents period, that's the only place. So if you picture tangent, this is the x-axis here and y-axis, negative pi over 2 and pi over 2, and at pi over 4, it equals 1, and that's the only place it equals 1. Okay. And what we're going to do is we're going to write plus pi n. Now remember, we're writing pi n here because tangents period is pi. Instead of 2 pi n. Okay, but remember, we're not actually working with theta, we're working with 3x. Okay. So what we need to do then is solve for x, and dividing by 3 or multiplying by 1/3, we have pi over 12 plus pi n over 3. And this will be our answer when n equals 0, 1, 2, and so on. But there's one other thing that's different about this problem, and it's up at the top. It says we just want the angles from 0 to 2 pi. So what we're going to do is we're actually going to plug in values of n until we can't plug in anymore. So I have n equals 0, n equals 1, n equals 2, n equals 3, n equals 4, and we'll see how many are too many. Okay, so n equals 0. X would be pi over 12 plus 0 here, we'll just make this whole thing 0, pi times 0 over 3, and that would just be pi over 12. So the next one we can plug in 1, pi over 12 plus pi times 1 over 3. So that's pi over 12 plus pi over 3. Simplifying our fractions here, or having a common denominator, I can multiply by 4 over 4. So I have pi over 12 plus 4 pi over 12 equals 5 pi over 12. So we've got one answer, two answers, and we can continue this process until we reach 2 pi, because that would make it too many. Okay, so I'm going to zoom in on this part for a little while so you can see it a little bit better. And now let's go ahead and plug in 2. We have x equals pi over 12 plus pi times 2 over 3. And I'm not going to go through all of this work every time. If we simplify this, we get 3 pi over 4. That's still less than 2 pi, so we're still good. I can do it again. X equals pi over 12 plus pi times 3 over 3. And that'll give me 13 pi over 12. Okay. I'm kind of running out of room here. I'm going to move this down a little bit. Okay, so we have x is equal to pi over 12 plus pi times 4 over 3, and simplifying that, I get 17 pi over 12. This is still less than 2 pi, so we haven't reached our last answer yet. I'm going to move up here. X equals 5, or n equals 5. So x equals pi over 12 plus pi times 5 over 3. And simplifying that, we get 7 pi over 4. We know that that's getting close to 2 pi, so we know we've got to run out of answers here soon. N equals 6, x equals pi over 12 plus pi times 6 over 3. Now this right here tells me it's too big. 6 divided by 3 is 2. So adding 2 pi to something is already going to be more than 2 pi. So really you want to use this term right here to figure out what your last one is going to be. So this is too big. So we can't use that one. So then what that means is our answers are pi over 12, 5 pi over 12, 3 pi over 4, 13 pi over 12, 17 pi over 12, and 7 pi over 4. From 0 to 2 pi, those are all the spots where tangent equals 1. Okay. So let's move on to our next equation. I know this one was a lot of work. You may need to stop your video here and kind of process for a minute. Let's move on to number 3 though. And we have sine x over 2 equals root 3 over 2. And again, because we have this coefficient here on the x, we're going to have to do the same thing that we just did here. So we have, I'm going to rewrite this as sine theta equals root 3 over 2. And that happens where theta equals pi over 3 and 2 pi over 3. And so we're not actually working with theta though. We're working with x over 2. So that happens at pi over 3 and 2 pi over 3 plus 2 pi n. But we don't want x over 2, we want x. So I'm going to multiply by 2 on both sides. And what that gives me is x equals 2 pi over 3 plus times 2 would be 4 pi n, and x equals 4 pi over 3 plus 4 pi n. Now obviously this is too big because it needs to be between 0 and 2 pi. So adding 4 pi even one time is going to be too much. What that means is my answers then are just x equals 2 pi over 3 and x equals 4 pi over 3. Okay. We're going to go ahead and move on to the next example here. So we have 2 cosine squared plus cosine x minus 1 equals 0. Now, this looks like a really long, complicated problem, but it actually looks a lot like a quadratic pattern. So we're going to use something, a quadratic pattern, remember, is ax squared plus bx plus c. We're going to use something that you'll end up using in calculus a lot, and we're going to call it a U-substitution. Okay, what that means is I'm going to let u equal something. I'm going to let u equal cosine x. And if I do that, then I can replace this with 2u squared plus u minus 1 equals 0. And now that's something I know how to factor. So I'm going to go ahead and factor this. And you can use whatever factoring method you want. If you want to use the x method or quadratic formula or whatever, we're going to end up with 2u minus 1 and u plus 1 equals 0. That means u equals 1/2 and u equals -1. But remember, we invented u. So we really have is cosine x equals 1/2 and cosine x equals -1. So there's no coefficients here on my x, which is nice. Cosine equals 1/2 at pi over 3 and 5 pi over 3. Cosine equals -1 at x equals pi, and we're just looking at from 0 to 2 pi. So those are my answers. Again, we didn't have to do the n thing because we're just talking about from 0 to 2 pi, and there's no coefficient here. All right. So I'm going to go ahead and stop us here. This will be part 1 of the video, and then I'll pick up with number 5 on part 2.